All right, let me first start off by saying that the markers on the board might not be the most visibly seen from what we can see on our preview panel. We're hoping it's a little bit better. If you can't see it, I apologize, but I hope the overall lesson gets through to you, the audience. So let's go ahead and get started. All right, guys, eyes on me in 3, 2, 1. Thank you very much. Today during class, we're going to learn a method of conversion. This will help you as we continue through physics. It could also help you in chemistry for those of you who are in my class. It could help you in any of your biologies, so on and so forth. And this method is called, I call it the train track method, because you'll see we kind of draw one half of a train track. A quick review. I know all of you know your multiplication and your division. But if you remember yesterday, I said there were a few things that we might need to study, and I asked you to flashcard them last night, and today you'll know the reason, and that is, in order to use the train track method, we have to have known units of conversion. Okay? We talked about 3 of them in particular. Everyone, I would like you to grab your whiteboards. Thank you, everybody. Okay, so one of the ones that I asked you to memorize was how many centimeters per inch. Can everyone write down on their whiteboards how many centimeters are in an inch? Remember, this is an exact conversion. Okay. All right, everyone, boards up. All right, looks like most everybody got it. For those who didn't, we know that for every 1 inch is exactly 2.54 centimeters. This is a known measure. This must be committed to memory. I know, kind of sucks. That's the way it is. The next one was how many cubic centimeters are in a milliliter. This conversion gets us from area, staying in the metric system, but it gets us from area to volume. Okay, so how many cubic centimeters per milliliter? All right, everyone write that on your whiteboards. All right, and whiteboards up. Awesome. This was an easy one, right? Everybody should know that every cubic centimeter is equal to 1 milliliter. That's our easy one. But again, it gets us from area to volume. All right, the other one is fairly simple. We're not going across, say, metric to standard, but it was just how many feet are in 1 mile. Everyone erase your whiteboards. Let's do the next one. How many feet in 1 mile? Go ahead and write that down. And up. Great. I figured a lot of you would know this one. For every 1 mile, there are 5,280 feet. So those are really the 3 ones that are really key in converting different things, okay? Why do we need conversions? Now, conversions we do every day. You may not know it, but you do conversions every day, or you're at least reading things in conversion every day, right? Tom, it looks like you've got a soda there. How many ounces are in that? Oh, it doesn't tell you? Right, it says 1 liter, doesn't it? Well, if I asked you how many ounces were in it, how could you tell? Right, at this point, you probably couldn't tell. We're going to learn how we can do that. This not only helps in sciences, it also helps in baking, right? You convert different fractions, different measurements as you're baking. This can help there. It can help in any world travel. I know some of you are taking the world history or going to France, right? For the school trip. And guess what? Things are going to be in the metric system there. So conversions not only help us in science, it helps us in life, it helps us in travel. Things are converted on a daily basis. So let's get started with the train track method. To start, we want to draw a train track. Like I said, it's kind of a half of a train track. But there you go. Okay? I'm going to give a first example. If I just wanted to do a simple conversion, say I wanted to know if I had 200 yards. Well, that's not showing very well. If I was going 200 yards, I want to know how many meters that would be. Okay? So we take our original information that we have and we place it in our first train track area. Anytime you see a line, like our middle of our train track, think of this as the word per. If we were doing feet per second, miles per hour, we don't have a per, okay? We only have yards. So we're going to start with 200 yards. Now we need to get to yards per meter. In order to do that, we need to cancel out yards and eventually get to meters on the top. Well, how do we cancel out in division? One on top, one on bottom, correct? Great. So we're going to move yards down here, and we know that that's going to cancel. But we need a known unit here of some kind of yard to a known unit. So what's a very, very simple one? We know that for every 1 yard, we have 3 feet. Correct? Now, in your mind's eye, or maybe even with a pen and marker, we can write a slash through there. We know that we have now divided out our yards, and we are currently at feet. We didn't want feet, right? We wanted how many yards to how many meters. So we need to keep going. 3 feet. Well, we know we need to put feet on the bottom, and we need a known unit of conversion. Well, I know that for every 1 foot, there are 12 inches. Right? Great, that's a known measurement. We can cancel out our feet over there. We're now at inches. I know that for every 1 inch, we had our conversion that we needed to know. There are 2.54 centimeters. We can now cancel out our inches. And we can see the only unit of measurement left is centimeters. So we have gone from standard to metric, but we're not quite there yet because we wanted meters. Well, that's very simple, right? We know that for every 100 centimeters, we get 1 meter. So again, we can take and cancel out our centimeters. And the only unit of conversion that you see left is meters. We've canceled out yards, feet, inches, centimeters. We have meters left. Now we do the famous plug and chug. Everything on the top line, you will be using your calculators in a parenthesis. So we have open parenthesis, 200 times 3 times 12 times 2.54 times 1. Close your parenthesis. Everything gets multiplied across the top, and then it is divided by, open a parenthesis, everything multiplied across the bottom. 1 times 1 times 1 times 100. Close your parenthesis. Go ahead and we would hit enter. And we would find, I used my cheat sheet from earlier, that it is 182.88 meters. That is the train track method. There's one more example that I'll give that has the bottom. I will move through it a little quicker. If you have questions, please stop me. But the next instance will give us something here, and we'll see how that works. So I'm going to go ahead and erase this. Actually, I'll erase all of it. We're going to need more squares. Okay, if I were to ask something to the effect of, if I was traveling at 300 miles per hour, how many meters per second would I be traveling? We would need to know that we have 300 miles per hour. How many meters per second? We have per, right? So here's our line for per. Per. We know we start with 300 miles per hour, per 1 hour. We'll do miles like that. Let's start by picking one or the other. We can convert the bottom or we can convert the top, leaving the other one for later. Let's start with the top. We just did this, just kind of in a different form, but 300 miles. We know that for every 1 mile, there is 5,280 feet, right? We can cancel out mile. Our next conversion, we have to get rid of feet. So we got feet down here, and we need a conversion. Well, we know for every 1 foot, there are 12 inches. We can cancel out foot. Continuing on, we need to get rid of inches. Here's our chance to get into our metric system, right? So we know that for every 1 inch is 2.54 centimeters. We're now into our metric system. Okay, we can cancel out inches. Next, we need to get from centimeter to meter, easy enough. Put our centimeter down here. We know that for every 100 centimeters is 1 meter. We can cancel out centimeters. So as far as our distance, we've gone from mile and we have meter. So if we were to look, the only unit of measurement up top is meter. We have our line, which is per, and our measurement down here is hour. So at this point, we are at meters per hour. Well, we want meters per second. So now we have to get rid of this hour. Let's do that by doing for every 1 hour, right? So we've set our hour and hour. We can get those canceled out. For every 1 hour is 60 minutes. Okay? One more box. We need to get rid of that minutes. So we put minute here. We know that for every 1 minute is 60 seconds. We can cancel out our minutes. The only thing we're left with on the bottom is seconds. The only thing on top is meters. So meters per second. Since we are at our known units that we need, it is now time for the easy part, plug and chug. We open our parentheses, we add them, or we multiply the products across the top. 300 times 5,280 times 12 times 2.54. I'm going to go ahead and leave out these ones, right? Times 1 times 1 times 1 doesn't change anything. But if you had to, times 1 times 1 times 1. Divided by, open our parenthesis again. Everything across the bottom. 1 times 1 times 1 times 1. 1 times 100 times 60 times 60. Very, very easy. So we've done this in our calculator. We go ahead and we plug and chug it. We hit enter. We find out that the answer is 134.112. Meters per second. So if I'm traveling at 300 miles per hour, I'm traveling 134.112 meters per second. So those are your two examples that I've given you, that we can do this. If we have that per anywhere, we know that there's a line, okay? So I'm going to go ahead and erase this, and everyone should have their sheet I passed out. A single problem on their sheet, okay? The problem says terminal velocity, the average terminal velocity of a skydiver falling belly to earth is about 200 kilometers per hour. How many feet per second is this? I would like everyone to take 5 or so minutes using the train track method. Remember, we have per on both of those. We will be changing not only distance, but also time. So keep that in mind. Take 5 minutes and attempt that on your own. I would use this time and they would attempt this problem on their own, of course. Okay, 5 minutes is up. Everyone in your partners, your desk partners, discuss with them, compare your answers, and let's come to a consensus. Each group will put the answer that they are going with on a single whiteboard to show me. Go ahead and take a couple of minutes and do that. Of course, we give them a couple of minutes. All right, everybody, let me see your boards. Great. Looks like most have got it. I see a couple of groups who did not get it. Let's go ahead and do this one together. So we know that we are falling, or the skydiver is falling, at 200 kilometers per hour. 200 kilometers per hour. We want to know how many feet per second. Feet per second. So let's get our train track, our per across. We know that we have 200 kilometers per 1 hour. Okay, we're going to start there. Jana, what do you want to tackle first? Kilometers? That's a good idea. Let's tackle kilometers. So if we're going to do kilometers, what should we put down here? That's correct, kilometers again. Now you probably have a known unit of measurement, right? What can we put here? You want to go with 1 kilometer, okay? And what would be our known conversion up here? Meters, okay? You want to do 1,000 meters. Okay. Andrew, what's right here? We're at 1,000 meters. We've just canceled out our kilometers. Should we continue on with meters? Great, I like your answer. What do we got? What's our next known unit of conversion? Go ahead, give me top and bottom. Okay, so you're saying on bottom we're going to have 1 meter to cancel out our meters, and on the top you're going to do 100 centimeters. All right. Okay, Alicia, what should we do next? Top and bottom. Okay, we want to cancel out our centimeters, right? And you said you wanted to do 2.54 centimeters. And we know that's correct for every 1 inch. Good job. Okay, next we are now we are out of our metric into standard. I'm going to go ahead, if you don't mind, I'm just going to cancel out what we have. We are now in inches per hour, so we're almost there. We need feet per second. Okay? Let's go with Sally. What should we do next? Awesome. Yeah, very simple at this point, right? 12 inches on the bottom, 1 foot on the top. We can cancel those out. We are now at feet per hour. Now we obviously have to cancel the bottom one, correct? Right. Brad, what do you think we should do now? On this side? Okay. So we're going to go ahead and bring hours clear up from the bottom to the top. That's right, Brad. So for every 1 hour, you said it is 60 seconds, 60 minutes. Okay, and we can see we can cross out this hour and this hour. Good job, Brad. Okay, last one, Emily, what should we do? Exactly, right? We're just at minutes at this point. We need minutes up to the top. For every 1 minute, you said it is 60 seconds. And we can cancel out minutes. We are now at, on the top, feet per, there's our line, I did not put our per over here, per, and we are left with second. Feet per second, that's what we're looking at. Plug and chug. Open our parentheses, 200 times 1,000 times 100 times 1 times 1 times 1 times 1. close our parenthesis on our calculators. Divide that by, open parenthesis, 1 times 1 times 1. Sorry, 1 times 1 times 1 times 2.54 times 12 times 60 times 60. Okay, so this is what our calculator should look like. And if you plug that answer in, you should get 182.269 feet per second. Are there any questions? Everyone got that answer? Does everyone understand how we're doing this? Great. I'm going to give you a couple more practice problems. We'll do this for about the next 10 or 15 minutes. Make sure we understand it. I'll be walking around. If anybody has questions, please ask me. We'll get this squared away so you guys can start on difficult conversions later on as we move through physics.